Hello everyone and welcome to the channel. I'm Emmanuel, I'm an airline pilot, and welcome to our climb tutorial in the JustFlight Avro RJ100. We are passing through the transition altitude now, so let's go ahead and set our altimeters to standard. There is no easy button for a quick setting, but you actually have to dial it back manually, which just happens to come like that with the aircraft. Now, as we are climbing, there are going to be a couple of considerations for us when we pass our acceleration altitude at 10,000 feet. The question is, which speed are we going to fly? And there is no direct answer to that. Different operators are using different speeds. So, for example, Swiss has been using 260 knots and Mach 0.67 in the climb. Others may be using 280 knots and Mach 0.67 or a totally different Mach number. There are several different procedures for this. Now, since we are flying Swiss today, in this tutorial I will use 260 knots and on conversion Mach 0.67. Passing through flight level 100, a couple of things for us to do. So we move up here, turn the runway exit lights off, the landing lights off, and when the aircraft is in a stable flight condition where there is no risk of any turbulence or any passengers getting injured, we can also turn the fasten seatbelt signs off. If you've been departing at night, also turn off the logo light at this moment. Now, let's go ahead and talk about a couple of the different things for us to consider during our climb. In general, you will notice that the RJs do not climb very well. Right now we can consider ourselves lucky that we get 2,500 feet a minute out of the aircraft. Believe me, it can be much worse. You can get as little as, 500 to 600 feet a minute once you get to a little higher altitudes. Now, let's go ahead and set our MCP up to flight level 280, which is going to be our cruising altitude today. Here we go. So, whenever you are flying through icing conditions, the engine anti-ice needs to be operated. I know I'm repeating this like the Bible in every single one video, but this is important. On the Avro, it is more important than on other aircraft for a simple reason. Let's go ahead and have a look at our aircraft's performance. We're climbing at 2,100 feet a minute right now. Now let's see what happens if I turn on the engine anti-ice. Engine anti-ice is on. You can see our engine thrust is decreasing because bleed air is taken off the compressor section. And now look at our rate of climb. We've just lost about 500 to 600 feet a minute rate of climb. And this is normal for the RJs. If we were to turn on the wing anti-ice, things would go even worse. I'm just going to turn this on to demonstrate it. Our engines are running even lower now. And now look at this. Our rate of climb goes down to almost 1,000 feet a minute. For this reason, be sure to use your anti-ice in a proactive way and be sure to keep your head around your anti-icing. Now, wing anti-ice and tail anti-ice are normally only used as anti-ices, not as de-ices. What does this mean? It basically means you wait until a little bit of icing has built up on your surfaces, and only once ice has built up, then you turn it on to heat the surfaces, which is going to dissipate the ice from your aircraft. Once the ice is gone, you turn the wing and tail anti-ice back off again. Engine anti-ice, however, needs to be turned on whenever you are entering expected icing conditions. Now, we are not in icing conditions at the moment, so let's turn it back off. But what would icing conditions actually look like? Let's talk about it. So in general, we are talking about icing conditions when the outside air temperature is between plus 10 to minus 40 degrees. We can find the outside air temperature on a gauge located down here. As you can see, it currently reads minus 6. Now, you can also go to the progress page and hit the next page button, and up here you're going to find your static air temperature. Now, engine anti-ice needs to be used when the TAT, that's the one located over here, is below plus 10 degrees, and the SAT above minus 40 degrees. And then engine anti-ice needs to be turned on proactively. Now, as we're climbing up to a higher altitude, we are eventually going to reach a speed where our indicated airspeed has to convert into a Mach number. Now, that is the case roundabout at between flight level 245 and flight level 300, depending on the speed schedule that you have chosen. Now, the RJ might turn over from a constant speed climb like we are doing now at 260 knots to a constant Mach climb automatically at flight level 245. When it does that, but you have not reached your target Mach number yet, remember we are climbing at 260 knots and on conversion Mach 0.67 today, then you might need to use the changeover button located over here in order to switch back to an indicated speed. As you can see, if I press the changeover now, it starts to maintain a constant Mach number and reads the same on the FMA, but we don't want to do that just yet, so let's continue to climb at a constant indicated airspeed here for now. Every 10,000 feet in the climb, you need to run the system checks. The system checks can be found on the checklist if you pick up the second page. And the system checks are as follows. Engine air, on. So we look up here and verify that the engine air is on. Engine air basically is your engine bleed. APU air, off. APU air, verify that it is off. Packs, on, and the aircraft is pressurizing. So the packs are located up here, and we verify that the aircraft is pressurizing by observing a rate of climb and by observing a differential pressure. When we have a differential pressure between the inside and the outside, then we basically know the aircraft is pressurizing. Then we continue, APU, stop. So verify that the APU is stopped so that it doesn't run for the entire flight. Lights, off. Again, runway exit lights, landing lights, and the logo light have to be off. Flaps, up. And they are showing 0. Gear, up, which it is, as you can see on the landing gear indicator lights. TRP, climb, so that's your thrust rating panel over here, and we make sure that climb is selected. Altimeters, cross-checked, and note that it says cross-checked and not standard. The reason for this is that if you're flying, for example, in the United States or in general at airfields where the transition altitude is higher than 10,000, on the first check at 10,000 feet, so on the first time we run the system check checklist, we might still be on local QNH. For this reason it says altimeter cross-check, so be sure that the altimeters are actually set to a setting where they are supposed to be, where they are appropriate to be. And that completes the system checks. Now let's go ahead and talk about a couple of standards that we are using. Now, by default you can see LNAV is the navigation mode that we want to use. Level change is the climb mode we want to use. And now you will probably say, but wait a moment, I've got eyes. I can see that there is a VNAV button over here, so why don't we use it? The answer is, when the aircraft has been developed by Avro, they wanted to make it future-proof. When the aircraft was originally developed in the 80s and early 90s, they didn't want to put a VNAV system on there because they simply didn't see the need for one. However, they thought, well, we are probably going to do it in the future as VNAVs get more widespread, so they just put the button in it. However, when you press it, you will notice that nothing happens. That's because the aircraft does not have a VNAV system. The same, by the way, applies for the microwave landing system switch over here, and if you're now saying what the heck is a microwave landing system, that's exactly what I wanted you to say, because a microwave landing system was meant as a replacement for the instrument landing system, ILS, in the 80s and 90s, but it never really made it through the test stages on a couple airports and was abandoned thereafter because ANAV procedures came up, and ANAV is a lot more effective than an MLS. However, as Avro wanted to make the plane future-proof and thought that MLS was the future, they put the button into here, even though it is not actually used. Now, as we're climbing up into the higher altitudes, you can really see how our rate of climb is deteriorating. Passing level 235, we only do 1,000 feet a minute over here. If air traffic control needs you to climb faster, then you have the possibility to change from the climb norm rating to a climb max rating. And if we do this, you can see our thrust is increasing quite a bit, and now let's monitor what our aircraft's rate of climb is going to do in response. Right now, not all that much. Well, I guess we are already at maximum power at this moment, so it's not really doing anything just yet. But let's go back to normal climb power, and in many cases you will see some differences there. As I've mentioned earlier, we got to monitor that our aircraft does not automatically switch to a constant Mach climb, so be sure that you keep your eyes on this and that you keep the airplane flying at the speeds that you want to fly and not at the speeds that the plane might want to fly. You are in command, you tell it what to do, even if it sometimes has those little tidbits of changing things around automatically. So as mentioned, we are climbing at 260 knots and on conversion Mach 0.67. At some later stages where the Avro really became an old airplane using a lot of fuel, some operators switched to a constant Mach climb at Mach 0.63. Now, whether or not you want to do that, totally up to you. You might find even more numbers in the product manual, because just like I mentioned, there is no fixed definition of what speeds to use. Every operator will establish their own system. One will say if you want to go fast, you fly 280 knots and then Mach 0.67 on conversion. Others will say 250 knots and Mach 0.63. Others will say 260 knots and Mach 0.67. So you get the idea. It's really different decisions by every different operator, which makes it rather hard to make a general statement here. For me personally, 260.67 works quite well. 280.67 also works quite well. In any case, the important thing here is that you know what you're doing. And that is the most important thing to take away. Have a plan, execute that plan, and you fly the aircraft, not the other way around. So if you need any help with the climb procedures, I do once again recommend to have a look over here. As you can see, the climb profile is also listed on here. As you can also see, there is once again different airspeeds listed over here, but the most important things are listed over here. So 10,000 feet, set your altimeter setting as needed, be sure to set your cruise altitude, run the 10,000 foot checks, run the periodic checks every 10,000 feet in the climb, and 1,000 feet prior to level off. This is something important once again. 1,000 feet prior to level off, verify that you're in either IAS or Mach hold mode. The aircraft is going to behave very similar to the level change mode if it is still in toga mode. However, it's not going to capture the altitude. So 1,000 feet before level off, verify that you're either in level change or in vertical speed. If you're still in toga mode, the aircraft is not going to level off. It will bust the altitude. Very important to remember that. So let's use the last 2 minutes it takes us to get up to cruising altitude to decide on the actual cruising altitude itself and talk about what normal cruising altitudes are in the RJ. So there have been different options for the oxygen system and for the cabin pressurization system in the Avro. Now, most operators did not have the enhanced system and did not have the additional crew training needed to fly above flight level 310. This means for most airlines your highest achievable flight level is 310. However, some airlines do have that additional requirement, and the airplane can climb up to flight level 350 in those cases. For most flights that are in the length of about an hour to an hour and 30, you would go anywhere between level 280 and level 300. My personal recommendation here is to run different SimBrief calculations for different altitudes to verify where you have the least fuel usage, since SimBrief does not automatically give you the best cruising level. It may not give you the best cruising level. So run different calculations, determine the best cruising level based on your SimBrief calculations, and then I recommend that you simply climb up to that level. In our case, today flight level 280 was the most economical level. Finally, we are now reaching our cruising altitude, so you can see altitude acquire mode has turned on, and now it's just changed to altitude hold mode. With that, we can change to our cruise Mach number, which is 0.70, and that completes our climb tutorial. Thank you very much for watching. I do hope that you have learned something today. As always, be sure to like, comment and subscribe, and if you really love what I'm doing on this channel, I would appreciate a small donation through the Buy Me Coffee link in the video description below. Thank you very much for watching, and I'm looking forward to see you all again on the next one.